Hello, intelligent automation community. Josh Noble back for another week. If you haven't been able to tell so far from the get-up, we've got a little bit of a special edition this week. It will be a longer video, but it will be particularly useful for anybody trying to automate applications on Citrix. In particular, if you're in healthcare trying to automate applications on Citrix. And that's because most healthcare networks implement Epic and Cerner, their EMR, EHR applications. They implement them within Citrix virtual apps or Citrix Zen desktops. And so to help explain how software robots are set up to automate Epic and Cerner, I've recruited the help of Wally. So this is a tactic that taught an entire generation how to bring back dinosaurs, so maybe it'll be helpful here.
If we looked at screens like these once a second for 8 hours a day, it'd take 2 years to look at the entire DNA strand. It's that long.
And that might actually be the best pitch that I've ever heard for the need for robotic process automation. So for our purposes today, let's call this my desktop mock-up, and I bring this up because when automating most systems, you install the RPA software robot on a virtual desktop. And once it's installed on that virtual desktop, it can access all the same applications as your human users. You then teach the software robot how to navigate applications and how to perform work. In Blue Prism, the software robot also recognizes additional elements within the embedded target fields. If you've ever right-clicked a web page and clicked View Source, you've seen those types of attributes. And let's call this texture an application's digital fingerprint. So when Wally is inside the computer, he can basically grab a button and know exactly what that button is based off of all the extra little elements, the extra texture, the digital fingerprint of that button, so that it's always working with the right field, the right application, and moving and manipulating the right things. If we want the software robot to automate systems like Epic and Cerner, then the most straightforward approach is to set those up to work just like any other desktop application. And this is done through the Epic or Cerner thick clients. And if you already use Epic or Cerner's thick client, then automating those systems is fairly straightforward. However, most healthcare IT departments haven't set up the Epic or Cerner thick clients, so special approval might be needed to install and support the thick client approach. If you aren't using the Epic or Cerner thick client, then more than likely your healthcare IT department has set up Epic and Cerner for access within Citrix virtual apps or Zen desktop. This is really common. These are separate virtual desktops that will spin up as needed, and then an employee can dial into the virtual desktop from any device. This non-persistent architecture provides a lot of flexibility and savings for a human workforce and hospital staff that isn't working 24/7. We can repurpose those machines around throughout the day. However, this is not exactly an ideal approach for RPA software robots that should be really working around the clock. Now, if the RPA software robot lives on a virtual desktop outside of Citrix, but then the electronic medical record system can only be accessed by dialing in and spinning up an application within a Citrix virtual desktop, well, we've basically installed a plate of glass in between Wally, their software robot, and the application that he wants to interact with. Wally can see the buttons on the screen, but he can't feel them anymore. He can't use that full range of the digital fingerprint because, well, again, we have a plate of glass in between. Okay, so if no other options exist, then our software robot here can completely rely on images on a screen. This is an approach known as surface automation or computer vision. And this all-visual approach typically starts with marking XY coordinates. The problem is using this single identifier, and really using a single identifier in most ways that we might spy an application, is going to result in very brittle automations because eventually the user interface is going to change. These screens are going to update. Our systems are going to update. So consequently, multiple unique identifiers should be used always when we're dealing with surface automation or computer vision to create more resilient automations. Okay, so I realize we're not talking about time-traveling murder bots here, but still, cross-referencing multiple fields to confirm a match is critical when we're talking about automating medical systems. These identifiers can be additional reference coordinates, fonts, colors, other reference points. So for example, I could have a point right here and tie that back to the original point. So if one of those moves, I know that that change has occurred. I might also do something like mark a color on the screen, and again use that as a reference point. So if something were to move, we know that the automation needs to be adjusted. Consequently, development of resilient automations when restricted to images alone is significantly more difficult because you need to design this type of resiliency into it. We need to take additional things to account, all those what-if scenarios. So if we can get in to actually use the digital fingerprint and not have to think through all of this, that's going to create automations faster, and again, they'll be more resilient. Okay, so let's say we want to expedite that design time and get back to using that full digital fingerprint. Well, the simple answer is we just get the robot back on the other side of the plate of glass. So again, let's clear this up, and we'll get Wally inside Citrix virtual apps, inside the Zen desktop.
We're going in!
Now, at first glance, this seems to solve all of our problems. We now have a software robot that is close again to the applications it's trying to interact with. It's not going through this plate of glass. It's able to interact with the digital fingerprint of target systems. However, this is actually the least common approach that we see for interacting with applications that live within Citrix. And the reason for that is something I mentioned earlier. The reason you roll out Citrix typically is that it's a flexible environment. These environments, these virtual desktops can spin up and spin down. They also typically reset back to their default state, their golden image, every time they're rebooted. Consequently, to have a software robot work reliably within a Citrix virtual desktop, special policies need to be put in place so that we don't remove the software robot and any modified files every time the system is rebooted. Additional complications can present from this configuration related to tracking activity through the Citrix console, firewall rules, and as I mentioned, reboot cycles. Basically, installing software robots on Citrix virtual desktops requires a lot of upfront IT support. Now, if you have an IT partner willing to set up a Citrix image specifically for your software robots, that's great. You're back to building automations that work a lot like you're dealing with local applications, a lot like the Epic Incerner thick client approach. So this last approach that I'm going to cover is fairly specific to Blue Prism. You may be familiar that Blue Prism's pretty good at playing with complementary technologies. In this case, Blue Prism is going to recruit a complementary technology found on the Blue Prism Digital Exchange from Ultima Labs. Instead of installing the full software robot on each Citrix virtual desktop, Ultima's IA Connect is a little agent, 4 megabytes, and it needs to be placed somewhere on a network drive available to the Citrix virtual apps or Citrix Zen desktop. So let's move our big software robot out right here. We'll get our little agent in place right there, and we're good to go. Now, when big software robot Wally needs to do work on Epic or Cerner, just like it did when we were using surface automation, big software robot Wally will spin up a Citrix virtual desktop. However, instead of performing everything through the plate of glass, through surface automation, through computer vision, we'll now have big Wally jump in, fire in a few commands, and pull in this little executable agent off of a network drive. That little agent Wally is now sitting on the Citrix virtual desktop, ready to do work for us. So now our big director Wally and little agent Wally from Ultima IA Connect, they're able to communicate with each other over existing Citrix virtual channels. By doing this, we allow our primary software robot to do all the command and control and design, except it's able to reach through this plate of glass over Citrix virtual channels and jump into the Citrix machine. It's able to communicate with Epic, Cerner, or any other applications residing within the Citrix virtual desktop. This allows automation designers to use the full range of that digital fingerprint that we've been discussing, leading to faster creation of new automations and hardened automations that aren't going to be so brittle when things move around a screen. It's not all image-based again. It also requires no Citrix side installs, no DLLs, no registry keys, no services to be changed, no impact on the Citrix real estate, no changes to the Citrix golden image, which is a big thing for IT teams. So as our automated work is being performed, the director on our software robot is communicating over Citrix virtual channels to Ultima IA Connect's little agent sitting on the Citrix virtual desktop. When work is complete, the little IA Connect agent drops off of the desktop. The Citrix virtual desktop is able to be shut down and reused by other people within the organization or other software robots within the organization. Now, there's a lot of additional benefits that comes with this approach around using Ultima's IA Connect when interacting with Citrix. Now, granted, that's probably also expected considering that Ultima was Citrix Worldwide Partner of the Year in 2019.
What I do have are a very particular set of skills. Skills I've acquired over a very long career.
So I should probably mention at least one of those additional benefits for you. So Ultima IA Connect does have a mouse over style spy mode for identifying target fields that Blue Prism is going to interact with on the other side of Citrix. Ultima IA Connect also has a different spy mode, which is a table style spy mode. Why would you want that if you can do everything visually and identify what to read and write and click? Well, Epic has a very complex, multi-layered user interface. It's this maze of overlapping fields with identical names in many cases. And so precisely identifying a field that's kind of covered by another field, embedded with another field, can be difficult with your just mouse over style hover identification techniques, and the table style gets us around that. If you have no idea what I was just talking about, it's okay, you're in luck. My colleague Corey Donahue filmed 3 demo videos showing various different aspects of the things that I've been speaking about within this whole video. Those can be found out on Blue Prism's YouTube page. As an honorable mention, I should mention that Blue Prism can access Epic's APIs to jump between the visual approaches we've been talking about today in this video versus a back-end approach through APIs. However, I haven't yet seen any customer use this approach, and that may be in a big way because the Epic APIs are somewhat new and still a bit limited. But time will tell. Maybe we'll see that here in the future. As always, I will put links down below to everything that we've covered today. Thanks again for tuning in. Look forward to seeing you next time. Hopefully you learned a few things about automating Epic, Cerner, or really anything on the other side of Citrix. Next time.